we finished the parametric equation lesson. Now we're on to polar graphs. This gets kind of weird. So, before we actually do any of the calculus part, let me actually show you how to graph things in what we call polar coordinates. This is not the rectangular coordinate system, but the polar coordinate system. And you're like, what? What does that mean? Well, points in polar form have this type of form, r and theta. R stands for the radius, and really that's the distance from the pole, and theta is the angle of rotation from the pole axis. Where is the pole? Right here. The center is called the pole, and this line that I drew in dark black, that's the polar axis. And as theta is greater than 0, we go counterclockwise, and when theta is less than 0, we go clockwise. So, first thing I'd like you to do is actually plot these polar points. Looking at A, 3 comma pi over 6. So what I do is, I'll look at my polar axis, and I'll rotate pi over 6 radians. So that would be this line here. This is the line pi over 6. Right, pi over 6. 2 pi over, I guess that'd be, 2 pi over 6, or pi over 3. This would be 3 pi over 6, which is just pi over 2, right? And so on. So pi, 3 pi over 2, all the stuff we learned in trigonometry. And because the radius is 3, we're going 3 units away from the pole, so 1, 2, 3. Here is point A. Okay? Can you try now to figure out where point B would be? So once again, 4 comma pi. Going to rotate pi units from the polar axis, whee, all the way here. And now count 4 units out. So 1, 2, 3, 4 units out. There's B. How about C when it's 3 comma negative 5 pi over 6? So negative 5 pi over 6 means I'm going clockwise. So negative 1 pi over 6, negative 2 pi over 6, negative 3, 4, 5. Here is negative 5 pi over 6. And it's 3 units, so I'm going to count 3 units away. Here is C. And lastly, D. So it's negative 2 comma 3 pi over 2. So let me quickly find 3 pi over 2. I'm going to rotate around all the way to here. But because it's negative 2, counting away would be 1, 2. That's positive 2. So how do I show something is negative? You guessed it, going opposite or backwards. So this is like negative 1. This is negative 2. So here is the point D, which is negative 2 comma 3 pi over 2. Okay, kind of weird with the negatives, right? So let me give you one more to try. Here's point E. Let me call it negative 3, negative 5 pi over 6. So very similar to C. I'm at negative 5 pi over 6, so that's there. But you see how C was positive 3? So I went 3 toward that. Well, negative 3 means you go backwards. Yeah, so opposite way. And so you'll see that A is also now the point E. So these two are equivalent, equal. So the note I want you to understand here is, look, if I have an R that's negative with a theta, that's equivalent to the positive value of R, as long as I take theta and add or subtract a pi value to it, okay, or half a rotation. That might come in handy. Okay, now that you've learned how to graph in polar form, can you now do some point conversions? So let's take a look at this rectangular point. So a rectangular point has the coordinates x and y, and our goal is to now rewrite them in polar form such that the following things occur. Okay? Before we do these cases, let's actually just plot where negative 1 comma root 3 would be. Here's now my, once again, Cartesian coordinate axes. Negative 1, root 3. So you're looking at this lovely triangle. And I hope you know that the radius here equals to 2. Good. So that's the position of this point. It's in the second quadrant. We know now that r is greater than 0. Very true. It's 2. So we can start writing that down. And now what's the angle theta? The angle theta here has to be positive. So the angle theta is just this angle that I'm measuring from here to there. Hope you know that the reference angle in this case, this angle here is pi over 3. So we're looking at pi minus pi over 3. Oh yes, all this lovely stuff from Math 12 or Pre-Calculus 12. There you have it. 2 comma 2 pi over 3. Now, what about if I wanted to represent that rectangular point? So the same picture, but in this case r is bigger than 0 still, so that's still 2. But now the angle theta is negative. So instead of it being that angle in green, I'm looking for this angle in black. And if you're thinking, well, that's just 2 pi over 3 minus 2 pi, you are correct. And that would be 2 pi minus 6 pi, or negative 4 pi over 3. Cool. Alrighty. Well, for parts C and D, I'm just going to redraw the diagram so that we can see it a little bit nicer. This time r is negative, so therefore it has to be negative 2, which really means that I'm looking over here now at my angle. Since the angle is bigger than 0, what I'm saying to you is I'm looking for this particular angle. Since I know the reference angle here is pi over 3, then 2 pi minus pi over 3, that's 6 pi over 3 minus pi over 3, or 5 pi over 3. So for part C, my polar coordinate is r being negative 2, and my angle being 5 pi over 3. And you can try the last one here, where r is negative, so once again negative 2. The angle is also negative. Excuse me. So a negative angle would be just that part. So that would be the negative pi over 3. Okay? So 4 different ways in polar form to represent the same rectangular form point. Crazy. Okay, how about number 3? And then we'll do number 4. Number 3 asks you to actually change the polar point to a rectangular one. So you can just draw this out if you want. 2 comma pi. So thinking, pi, that's over here, and then 2 means it's 2 units from the radius. So there you go. So hopefully you can see that's just negative 2 comma 0. Or if you're thinking, I want a more formal way of doing it, well, let me help you by instructing you to come over here. Conversion equations. Remember trigonometry? Yeah? Good. Remember this is the angle theta? Remember this is x, this is y, and this is r? Do you remember the relationships between all these things? Perhaps x squared plus y squared, that's an easy one. That's equal to r squared. Do you remember how we actually came up with something for x and y? Well, okay, let's do the tangent one first. Tangent ratio of the angle theta, that's just opposite over adjacent, so y over x. This one over here, what's x and what's y? Well, do you remember this? Sine theta, that's just y over r. So therefore, if I ask you for y, that's r sine theta. Remember that? Well, guess what? That's the conversion equation we'll use here. R times sine theta. And of course, for x, it's r times cos theta. So, method 2 involves you using the conversion equations we know that since x equals to r cos theta, r in this case is 2, the theta is pi, we can just evaluate 2 cos pi. Cos pi is equal to -1, so I know this point is -2. Similarly for y, since we have r is 2, and sine of pi, that's 0, 2 times 0 is 0, and there we have it, the same coordinate as my previous drawing, -2, comma 0. Okay. And how about number 4? How do we change this then from the point -3, comma 3 to polar form? Once again, it's up to you which method you like. If I just quickly draw the picture, here's -3, up 3. I know that I have this lovely picture. I can find the radius by using Pythagoras. That would be 3 root 2. I also know this is a 45-degree triangle, or oops, in radians, pi over 4 reference angle. So therefore this angle here must be pi minus pi over 4, or 3 pi over 4. So 3 root 2, comma, 3 pi over 4. That's just by drawing the pictures. Once again, if you don't like that, because you're like, that's just way too difficult for me to visualize and understand, I like just using regular formulas. Well, here we go. The conversion equations are here to help. X squared plus y squared equals r squared, so -3 squared plus 3 squared equals to r squared. That's kind of what I did there to actually find that r equals to 3 root 2. And then the hard part here would be figuring out the angle, but look, I gave you a conversion equation. Tangent theta is just y over x, so 3 over -3, it's just -1. And if you solve for theta, that's inverse tangent of -1. And yes, there are two particular solutions, but you know the one you want is in the second quadrant. So knowing that, you'll find that theta equals to 3 pi over 4. And once again, the same information to give you the same polar point. Whew. How are you feeling so far? Weird stuff? Yeah. Weird stuff means we need to do more practice. So, on to the next page. And I'd like you to try now these equation conversions. See if you can go from rectangular to polar. And once again, before we begin, I'm going to put at the top those conversion equations that are quite helpful. X squared plus y squared equals to r squared. Tangent theta is just y over x. And then x is equal to r cos theta, where y is equal to r sine theta. Okay? So with this, you should be now able to change everything from rectangular to polar. Notice these three equations all involve x and y. Your job to change it into polar is make it in terms of r and theta. So for number 5, since y equals to 4, that's a pretty straightforward one. I'm going to say, hey, y is now r sine theta. That equals to 4. So solve for r. That's 4 over sine theta. That's it. There's our equation. R in terms of theta. Similarly for number 6, now you can do the same thing. X is just r cos theta. Y is just r sine theta. Plus 2 equals to 0. And notice I have the r. I want to solve for r, so I'm going to factor out the r. And I get 3 cos theta minus sine theta. I'm going to do one extra step and move this positive 2 to the negative side, or the right-hand side, to make it negative. And now I can solve for r. It's just -2 all over 3 cos theta minus sine theta. Done. So I'll let you try number 7 on your own, but the same idea. Okay? Have fun. Getting scared yet? Yeah, but notice here, r squared cos squared theta, r squared sine squared theta, 2r cos theta equals 0. Notice here we have an r squared that I can factor out, and I'm left with cosine squared plus sine squared. What's that? I heard you say 1. Yay! And by the way, I could have just done that right here, right at the top. X squared plus y squared. That's r squared. Okay? Still, you need to solve for r. Let's factor. And since both of these equal 0, either r equals 0 or r equals to 2 cos theta. And I don't think r can be 0 in this case, so that just means that it's a point. And this we know is not a point, so r equals to 2 cos theta must be the correct polar form. Okay? Alright, conversions the other way, polar to rectangular. Alright, same idea. R equals to -2. Well, the only way I have r, looking at my conversions, are the x squared plus y squared equals r squared. So I'd ask you to square this first. So r squared equals to 4. And since r squared is x squared plus y squared, here we have it. That's the equation. So when r equals -2, this is the same thing as the equation x squared plus y squared equals to 4. And you should be familiar with that equation. What is that? That's a unit circle with radius 2. Right. And what am I saying with r equals to -2? Really? I'm saying, hey, it's always -2 away from the pole. So always 2 units or -2 units away from the pole. And since it's always that way, that means that it has a constant radius. So that totally makes sense. Okay, how do you try 9? I'll try the same idea. So square both sides, get 9. Actually, I wouldn't use square both sides. That would be like multiplying by r on both sides. And the only reason I like doing that is now r cos theta is like an x value. So this is like 3x. And then just like before, the r squared is like a x squared plus y squared. So here's your conversion. Okay? I don't know, I'll just leave it like that. The last one here, cosecant, that's the same thing as over sine. So then I can move r sine theta to the side, that equals to 2. And r sine theta equals to the y value, so in this case, y just equals to 2. Okay? Alright, so the next thing I like to do with you is actually go and sketch some polar graphs. Okay? Now, I'm going to use the help of a calculator to assist in a few of these, and then hopefully you can see the idea and then do the other ones that are not bolded without the calculator. So, what type of polar graphs can we get? Well, the first ones are circles. And to use your calculator to show you, I'd like you to bring out your calculator, go to mode, and in this case now, let's go down to the 4th line and shift over to POL. That stands for polar. Press enter. So now when you type in y equals to, you'll see that everything is in terms of r. Right. And our first equation here says r equals to 2 cos theta. So I'm going to still use that x thing. That's why this is x, t, theta, n. X is for function, t is for parametric, theta is for polar, and n I think is for sequence. So we're in the polar mode, it will then definitely just say polar, or the angle theta, as your variable. Are you ready to graph? Are you ready? Here we go. Let's press graph. Whoa. Okay, now by the way, I have my window in trig form. You can do it in trig form like this, zoom trig. Okay, before I didn't have it in zoom trig. So notice what happened again. graph created was a circle. Notice here, if I were to trace it out, notice where theta equals to 0, the x and y coordinate are 2, 0. So I'll just quickly draw that right now. 1, 2. Here's where I start. And now, once again, going back to my calculator, let's start tracing. And as I trace, the angle changes, right? And then look what happens when I get closer and closer here. Goes back to the origin of the rectangular graph when theta equals to, yes, that's pi over 2. Oh, sorry, that's not pi over 2. Yes, it is pi over 2. And we keep circling around. Here is pi. So it rotates around in pi units. Cool. And notice the radius is equal to 2. What do you think happens with r equals to 5 sine theta then? Can someone tell me what do you think the radius would be? Yes, 5. Good. Now what about the orientation of this circle? Well, if you didn't have a calculator, I'd be saying, hey, let's make a table of values. When theta equals to 0, what happens? Sine of 0 is 0. 5 times 0 is 0. Okay, so that means when the angle is on the polar axis, the radius is 0. So we must start there. Now, you can take other values of angles, and I would use the special angles like pi over 6, pi over 4, pi over 3, those ones. And plug it in for theta. But the next one I'll try is just pi over 2. So if I ask you now to evaluate sine of pi over 2, what's that? If you said sine pi over 2 is 1, that's correct. So 1 times 5 is? 5. And what's after that? Well, how about, yes, perhaps pi? So sine pi, what will that be? Yeah, you guessed it, that's 0. And you can make that 0. So, knowing that, go ahead and graph. And what do you see? 1, 2, 3, 4, 5. That's at pi over 2, so it must have went something like this. And then it came back down here at pi. Okay. Alright, so let's take a look at number 12. We're talking about now rose petal curves. You're like, what are those? So let's take a look. Graphing calculator, please. Bring it out. Turn it on. Press Y equals. Make sure you're once again in polar mode. And type in 3 cos 2 theta. Press graph and watch and be amazed. Whoa, 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 whoa. Ta-da. There you go. A rose petal curve. Notice it seems to start at, let's see, let's just press trace. 3 units away from the origin on the polar axis. So 1, 2, 3, it starts there. And then what happened as we trace? Went up and then back to the origin at 0.785. What special angle is that? If you thought about it, it's pi over 4. And then let's see what happens after that. It kept going down, 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 down. Now it's 3 units away here at 1.57. So 1.57, I hope you remember, is just pi over 2. It's 3 units away. And then we came back up like this. You can see it. And can you guess what value that is? 2.35. So that's approximately, what? Is that 3 pi over 4? Yep. And we'll keep moving over here to pi, and notice the value is 3, or negative 3, I guess. R is 3. But the x value is negative 3. And we'll come back around, and we'll loop-de-loop up, and then back down. And then once again, connect. There you go. Rose petal curve. Cool. What do you think will happen with 4 sine 3 theta then? Okay, I'll let you think about that. See if you can sketch this one without the calculator. And once again, if you are in doubt, hello, r and theta. And if you'd like me to really help you out, here, I'll give you the theta coordinates I'd use for this one. Since it's 3 theta, I'd use probably pi over 6, pi over 3, maybe pi over 2, 2 pi over 3. I'm going to just try 5 pi over 6 as well. And how about pi? Okay. Go ahead, have some fun yourself. Try it, and I'll come back and double check with you. Sine 0, 0, 0 times 4 is still 0. 3 times pi over 6, that's pi over 2. Sine pi over 2 is 1. So 4 times 1 is 4. So notice I'm starting here, and all of a sudden at pi over 6, an angle of pi over 6, let's pretend that's over here, right? On this axis, it is 4 units away from the origin. So 1, 2, 3, 4. So it's like me having a point right here. So I bet you the curve went something like this. Pi over 3 times 3 is pi, sine pi is 0. So notice at this point it went back to 0, so pi over 3 is probably a pole like right about there. There's pi over 3, and it's back to 0, so it's back here. Whoop. There's your first rose petal. So pi over 2, I'm going to times that by 3, that's 3 pi over 2, that's sine 3 pi over 2 is, I think, negative 1, so that's negative 4. So now at pi over 2, that is actually right here. I'm going negative 4 units, so 4 units the other way. 1, 2, 3, 4. And you'll see probably what happened was that the graph went like this. And I'll let you finish off the rest. This, I believe, is 0. So guess what? Comes back around here. Whoop. And then 5 pi over 6. That one, I believe, you'll get a sine value that is 1. So 1 times 4 is 4. So at 5 pi over 6, that's way over here. It's now 4 units away. 1, 2, 3, 4. So as we continue on, whoop, and then, yes, at pi, notice sine of 3 pi is 0, times 4 is 0. We're going to now plug this, and it'll come back to 0. Notice I could have continued this to 2 pi, but you would just repeat the process again. Cool. Alright. 13. What are limacons? Well, it's in bold, so you graph it out using the graphing calculator. So as you start using the graphing calculator to graph these out, if you're not too sure about how to do this by hand, when you graph, I'd ask you to look at how it's created. And once you've done that, also press trace to actually trace along to see what actually happens. Interestingly, this one actually starts, if I trace again, just want to trace, then theta equals 0, it starts at negative 1. So let me just plot the point negative 1 here, and that's where it starts. And notice again, as I trace, it kind of goes down and touches 0, and it goes up, and then over here it seems to have the y value of 2 before moving further up into this position up here. So as I come around to 0, I know it also comes and touches at 2, and then it comes around, and as we go around, where does it stop? Nobody knows. Well, the calculator does, at x equals negative 5 when it's pi units away. So 1, 2, 3, 4, 5. So at 5, and then we'll just continue back around. And then notice how it goes back to 0. I didn't draw that very well. Let's try again. Whee! Back to 0. Didn't draw that well again. Whee! Back to 0, and then around. Okay. There's my limacon. Okay. Can you try part B? And then one last one called a lemon skate when it's r squared. What do we do for that one? Okay, so why don't you take a look at B again, try this out. If you don't know where even to start, once again, make a table of values. I'll just use these values, and let's see what you can get. Okay, try yourself, please. Looks something like this. At pi, it's also 3 units away from the pole, and at 3 pi over 2, it's at 0, so 3 pi over 2 is this one. It must come back here to 0 somehow, and then goes from 0 all the way back like that. Kind of like a heart, I guess, eh? And if you want to double check the graphing calculator, let's try that. 3 plus 3 sine theta graph. Okay, so let me just change my window. And y max, let's make it 6. And I think you get the picture. Cool. Alright, the final one. How do I graph out r squared? Well, on your calculator you can't, because there's no r squared feature, so all you have to do is just take the square root of 9 sine 2 theta. And then, because it's really plus or minus, you should also put in the negative of it. So negative 9 sine 2 theta. And then graph, and let's see what you get. Woo! Woo! And there you have it. So notice it looks something like this and something like this. And if you're curious, I think at the pole here, you should see this is 1, 2, 3 units away. Okay? That's like pi over 4. Alright. Weird stuff, I know. So that's why we're going to stop lesson 9.2 here. I'll call this part 1. On the next page, I have a great summary of the different types of graphs and what they look like, so you can take a look at that. And then when you come back to class, we're going to actually practice with that before moving on to questions 15, 16, and 17. All right, see you later.